is what we have. Fixed time moment for BC, for AB and for CD they are 0, because in both columns you have no load. You have one horizontal load at column AB, but this load is applied on one end exactly, so your distance B is 0, if you consider the second case in your green card. But you have two loads that are applied on your beam. A uniform distributed load plus a point load. Yes, Trace.
Will there be situations where we have to do combinations with something like this?
This is a load combination.
Okay, so it's already factored in. You don't have to do the stack as a safety. Like when we have to use
What do you mean, what part?
You mean the load case combination?
Yes.
These values, the load case combinations, will give you W and P. This is what problem set 10 gives you. Guys, problem set 10, part 1, asks you to calculate the unfactored loads. So which are the loads that are calculated without the load case combinations, which is what we do in design. But in step 2 is visual analysis, okay, part 2, and part 3 asks you to use only one load case combination. The factored loads that you will calculate from the load case combinations will be your W and your P. Okay, but in our problems that we solve in the classroom, we do not use factored loads, and in all your problems so far, I don't think that we included factored loads. This is the first problem that you include factored loads, but this is what you do in reality. You have the externally applied loads, wind, rain, whatever you want to calculate, and then you need to factor them with the load case combinations, and the new values are your W, your P's, etc. This is what you have here.
Thank you.
Can you explain why the AB and CD are 0 again?
Okay, Corbin, would you like to help Selby? Yes?
How do you explain this? I can't explain
You
it.
took the second one, and the second one, point load is at B, so your, like the lowercase b in your equation would be 0. So it's just, you're gonna get 0. Times it, making that 0.
Okay.
What about
Good,
CD?
she said.
There's no load.
So, at AB, you have one point load that is applied at joint B. This is exactly at the end. So imagine that this P is applied here, so your B is 0. So this term is equal to 0 and this term is equal to 0.
Okay.
Yep.
Okay? And in CD, you have no loads. So there's no case with no loads here. Only this case, but you have a rotation already.
Great.
Okay? Any other questions?
Yes, but can we go back to the other sheet? Not this sheet, the one that we're working
The
on.
notes?
Yes. In the FEMCB, we take the 150 and we put it negative because it's on the other side, right? But then we multiply it again by that, or is that just saying we did this again, just negative?
Which is by that you said?
FEMCB equals 150. Are we multiplying? We're multiplying that by negative WL squared.
No. I'm just saying that this value
Okay.
it came out from this component.
That's what I thought.
Yeah, no, this is not a yeah, let me have it something. How can I write it? You can have it like this. No, you do not multiply this.
You were just saying like it comes from that
Yes,
negatively.
Yes, exactly.
Okay, cool.
But this minus 150 came out from this thing, from this term.
I was
Okay?
trying to make sure I was
So, psi A, B, and BA, we said that you have delta B. So psi A, B, and BA is how your column moves horizontally. Remember, the deltas that we have, the VA and VBs, are perpendicular movements to your component. So if this is a structural member, and this is your A, and this is your B, your VA will be perpendicular, and your VB will be perpendicular, 90 degrees. Okay? So here, our psi AB equals psi AB is equals to psi BA is equal to delta B minus delta A divided by L. But delta A is 0. So here we have delta divided by L AB, where L AB is equal to 20 feet. Psi BC and CB it is a vertical movement of the beam, okay? So psi b, delta b cannot move vertically, delta c cannot move vertically, so this is 0. And then psi cd equals to dc is equal to delta divided by L CD, and L DC CD is equal to 30 feet. Or we can write it as 2/3 of psi AB.
And when we're looking for psi, it's always going to be delta over the length of the
Members.
member.
Yes, but this delta in reality is delta C minus delta D. This is what we have here. But delta D is 0.
Could you say that one more time? Slower.
This delta is delta C
Delta C.
minus delta D. But delta D is equal to 0. And we said that delta C is equal to delta. That is the reason that we have only delta. If your D could move, then here we would have delta C minus delta D divided by the length. So it would be two unknowns, cell D. Not the one that we have here. It would be two different unknowns.
So then wouldn't it be 11 then?
Yes,
Not 10 unknowns.
exactly.
Either way, it doesn't.
Yeah, but this is for argument's sake. This is a
Okay.
fictional example. This is not what happens here.
Okay.
Okay, now that we have established this, let us go to step number 4. Which is step number 4? It's over here.
Apply equilibrium at joint.
Let us apply equilibrium to the degrees of freedom.
It's when it was wrong side, joints for the T1.
Oh.
Yeah.
And I asked, because he asked me, but I was so like confused what was going on. I was like, just say it again.
So we still haven't found our size, correct? Because we don't know what delta is.
Which ones?
Our size.
Which size?
The ones that aren't 0, we still don't know what they are because we don't know
Oh,
what
yes, you can write them down in your
Excel.
slope deflection equations.
But we don't know what they are. It's just
Which
delta over 30 or delta over 20.
Yes, this is not 0. This is an unknown.
Okay, so we still don't know what they are.
Yes, you will replace your psi in your slope deflection equations with delta over 30
Okay.
or delta over 20, whatever you have.
So
Because
how,
it's an additional unknown.
okay. So in Excel, how do we input that?
We'll see. We'll
Okay.
get there. Sad face again. Even with the equations of equilibrium for the degrees of freedom, we didn't manage to reach the required equations to solve it.
I think you meant 9 equations, 10 unknowns.
Yes. Oh, yes, my mistake. Whoa. Good eye. But we have not said our final words yet. We have some more aces in our sleeves. Step 5. And you will need this for problem set 10. Equilibrium of the structure. Let us copy our system. So this is our system. And you have AX, and you have BX. We also have AY, and we also have a moment here, MA, and a DY here, but we don't care about these, because they will not help us. We can have one extra equation here. Which is this extra equation? Sum of forces at x equals 0. And this will give us AX plus BX plus 10 kips equals 0. This is equation number 10. Now we have 10 equations.
But can you have the sum of moments of y? And
You can have this, which way?
It's not gonna
Sum
help
of
us.
moments where?
like y? You said the sum of moment of fx, the sum
The
of
sum,
moment
sum of forces at x, along the x-axis.
Okay, yeah. What about y? Because that'd be like another equation that you can do, right?
Because we need extra equations. We're trying to find which are the extra equations that will help us solve the problem. You can consider sum of moments as well, and sum of forces along the y-axis. In this problem, they will not help us. If we didn't know, now we know the solution. We know that they do not help us. That's why we do not include them. But we can include them in reality. We will see eventually that we will not need them. Okay?
So let's say we do include them. What would be like our end result? That kind of
It will not be a mistake.
okay.
You can include them. But, as you can see, we have 10 equations, but we added 2 extra unknowns. If you also add the moment, and the sum of moments, and the sum of forces along the y-axis, you will add more unknowns than the 2 equations that you will add for the moments and the sum of forces along the y-axis.
Sad face.
And now we're really sad.
He's crying.
And this is where we will stop, because we don't have that much time. Next time though, we will start with a smile. So,
this is still not enough to be able to complete step 3
but actually,
or part 3 of the homework, right?
I will tell now. Because we have the due date on Thursday, and you have your exam on Tuesday, and I would like to upload the solution problem set on Thursday so that you will have it. I will upload a video tomorrow for the remaining of this part. Please, it is not that much, only this column is unknown. Okay, so we have only one column here. It will be a short video, but please review it tomorrow. I will try to upload it before noon. Review this. This will be a very short video, like 10 minutes, 15 tops. Review it tomorrow and come ask me questions. You will need what we will discuss in problem set 10 in your mid-term exam number 2. And don't forget, there will be no formulas provided to you in the exam. You need to create your own one-page back and forth letter size by yourself. This must be handwritten individually. If there are two copy and paste same handwritten type, you will get a 0. I'm letting you know from now, this is already in an announcement. So if I type my notes, Emmanuel cannot take them, we will both get 0. Okay? And this will be provided when you submit your exam, and I will give it back to you after I grade your exams. Yes.
I know we're not gonna get anything else, but do we get the fixed and effects, like that graph, where like there's
The tables, I said this in the announcement, will be provided. So in your one-page back and forth cheat sheet, you can write whatever you want. Other than the tables, I will provide this to you.
Okay.
It's from what chapters to what chapters again?
From where we stopped in midterm exam 1 up to here. I think it is force method up to slope deflection method.
And
And
then ritual work was the last one.
I think so.
Ritual work,
And
yes.
will you give us like what we did for the first exam, where it gave us like what subjects are gonna be there?
I will give.
Okay, yay.
Okay, thank you for your time.
Okay. I feel like I got an exam now.